Let's talk about a word problem with GCF. For an intramural league, you need to divide 40 men and 24 women into all male and all female teams so that each team has the same number of people. What is the largest number of people that can be placed on the team? So one of the things that it says already at the top, it says you need to divide. Okay, we're not looking for something that they multiply into, we're looking at divide. So since we are looking for the same number to be placed in each team, we're looking for a GCF of 40 and 24. So first of all, we're going to take 40 and do the factor tree. So we have 4 and 10, and I know that 2 and 2 go into 4, and 2 and 5. So my factor tree for 40 is 2 to the third times 5. Now let's do the same thing for 24. We have 8 and 3, 2 and 4, and 2 and 2. So for 24, my factor tree is 2 to the third times 3. Now, we see that in both problems, only the prime number of 2 goes into them. And the smallest exponent is to the third power. So 2 to the third power is 8. So our greatest common factor in this case is 8. So what is the largest number of people that can be placed on a team? It's 8 people. Stop the video right now and try to do this one on your own. On this one, you're dividing to find the largest number of people that can be placed in a singing group, and in this one case, the largest number of people can be 96. Another word problem that we can look at is something for least common multiple. In this one, it's a movie theater and it runs its films continuously. One movie runs for 80 minutes and the second runs for 120 minutes. Both movies begin at 4 p.m. When will the movies begin at the same time? So since we're looking for something in the future, we're looking at a multiple, not of something that's been divided. The last one we were looking at the least amount that could divide into it. And this time we're looking for the least common multiple. So what we're going to do in this one is we're going to take 80 minutes and 120 minutes, and we are actually going to do a factor tree for both and find the least common multiple that way. So this one we can have 8 and 10, 2 and 4, 2 and 5, and then 4 goes into 2 and 2. So here's all of our prime numbers. So 80 is 2 to the 1, 2, 3, 4 times 5. And then 120 is the same as saying, so we have 12 and 10, 4 and 3, 2 and 2 for that, and then 10 goes 2 and 5. So I can actually say that this is 2 to the 1, 2, 3 times 3 times 5. And on the least common multiple, every single prime needs to be represented. So on this one we have a 2 and a 5. And on this one we have a 2, 3, and a 5. So we got to make sure they're all represented. And also, not only do they have to be represented, but we have to take the greatest exponent of each one. Notice that this one has 2 to the 4th, and this one has 2 to the 3rd. We're going to take the 4th power. The 3rd is only goes up to 1, and same with the 5th. Okay, so now what we need to do is actually multiply all these together to find out what our least common multiple is. If you multiply all this over, it's 240. So 240 minutes is when they're going to start again together. So we know it's 240 minutes. And we need to figure out, because it started at 4 p.m., we need to figure out when they are actually going to be together again. 240 minutes, if I take 60 into 240, that's the same as 4 hours. So if they started at 4 p.m., then they'll be back together again at 8 p.m. So that's our answer. So now I want you guys to take time to pause the video and try this one on your own, and then come back and check your answer. Okay, so you should have gotten 120 minutes. So it's the same thing as 2 hours. So on this particular one, if both movies started at 3 p.m., then they ended at 5 p.m. So hopefully that's what you guys got. And that's it for the word problems for the greatest common factor and the least common multiple.